Hey guys, welcome back to chapter 11. In this video, we're going to talk about concentration of solutions. We're going to talk about how we mathematically represent that, so just a review. And we're also going to introduce a new unit for concentration, which will be used in future calculations. So when we're looking at solutions, we prepare a solution. We can think of that solution as being dilute or concentrated. So a dilute solution is going to be a solution that has a small amount of solute particles compared to the solvent. In contrast, a concentrated solution is going to have a large amount of solute particles compared to solvent. So the silly example I always use is sweet tea in the north versus sweet tea in the south. So sweet tea in the north, let's say we're making a gallon of tea. We may put like half a cup of sugar in, right? So half a cup of sugar into that gallon of tea. There's just a few sugar particles floating around in that solution. Now sweet tea in the south, we're still making a gallon of sweet tea. We may put like 2 cups of sugar into that gallon of sweet tea. So if we peeked in there, we would see a lot more sugar particles in that same gallon of sweet tea. So I would say the first example is a dilute solution, very few solute particles. Sweet tea in the south is a very concentrated solution, lots of solute particles. We have quantified this idea of dilute and concentrated, and let's just real quick review that. So we've quantified that with a unit called molarity. So molarity is defined as the amount of solute in moles divided by the volume of solution in liters. And here was our formula that we saw for that. So we've got moles of solute, liters of solution. And so when we reported this, we would report it as moles per liter. Or we would report it as molar, right? It's like a 0.5 molar solution of that capital M. We want to introduce in this chapter a new unit for concentration. So there's all different kinds of units you can use. There's parts per million, parts per billion, percent concentrated. So there's all different types of units that we can use. So I just want to introduce one of the new ones, and that is molality. We have to make it nice and confusing and keep that like mole theme going on. We need more mole words, right? So molality is the amount of solute in moles, that's the same, divided by the mass of solvent in kilograms. So how is this different? Well, in molarity, it was the volume of the entire solution, everything included. Here, we're looking at just the mass, so different unit, and we're looking of the solvent being on the bottom. Okay. The formula for molality, we've used a lot of M's and N's in this class. But the formula for molality is just kind of like cursive or italic M. When I do it, it'll look kind of like this. So I use the cursive M. It has one extra little bump in it. But that's what we use. It's a lowercase kind of italic M. And then it's number of moles divided by the mass of solvent. So that's kilograms of solvent. So let's look at an example of molality and molarity question. So in this question, we're just going to review the idea or the concept of molarity and then also do one molality. So you prepare a solution by dissolving 17.2 grams of ethylene glycol in 0.5 kilograms of water. The final volume of solution is 515 milliliters. Calculate the molarity and the molality. If you'd like to challenge yourself, go ahead and pause this video and see if you can work it out. If not, I'm about to work it out with you. So let's start first with molarity, just kind of as a review. So molarity is the number of moles divided by the volume. I like to just take inventory of what I know and then know exactly what I'm solving for. So we've got molarity, that's my formula. I've got molarity, moles, and volume. So going back through, do I know the molarity of the solution? No, that's exactly what it's asking for. So I'm going to be solving for this. Here to the bottom, do I know the volume of the solution? Yeah, I do. So the final volume of the solution is 515 milliliters. Am I going to write down 515 milliliters? No, that has to be in liters. So just a quick refresher, remember 515 milliliters. If I want to convert that to liters, I put milliliters on the bottom, liters on top, and I've got, in 1 liter, I've got 1,000 milliliters. So we'd multiply across the top, divide by the bottom. So 515 divided by 1,000, that would give us 0.515 liters. Okay. So that's what's going to go over here in my little inventory box is, gracious, 0.515 liters. All right, so the next thing it asks for is the number of moles. Are we directly given the number of moles in this solution? We are not directly given the number of moles in the solution, but are we given enough information to determine the number of moles in this solution? Yes. So what a great opportunity to practice our grams to moles, moles to gram calculation. So here we've got 17.2 grams of ethylene glycol. So 17.2 grams, and ethylene glycol is that C2, gracious. C2H6O2. So then I draw my train tracks. Whatever unit I'm trying to get rid of is going to go down here on the bottom. So this is going to be grams of the ethylene glycol. And whatever unit I'm trying to get to, which is moles, is going to go on the top. So what numbers go into this train track in order to solve for it? So we've got to determine the molar mass or molecular mass of ethylene glycol. So here's where we go to our periodic table, and we would add up 2 carbons, 6 hydrogens, and 2 oxygens. So carbon is, looking at the periodic table, is 12.001. 12.011. I'm going to multiply that by 2. And then I'm going to add it to hydrogen, which is 1.008 times 6. And then I'm going to add that to oxygen, which is 15.999 times 2. So the molecular mass of ethylene glycol is, get my pen here, 62.07. All right, and with that, it is 1 mole 1 mole of ethylene glycol weighs 62.07 grams. So now to solve for moles, we're going to multiply across the top, divide by the bottom, noting that grams, I didn't mean to erase it, but grams and grams cancel. We're left with the unit of moles. So I'm going to take 17.2 times 1 divided by 62.07, and I get this equals 0.277 moles of this guy. So moving forward, I will not write out the grams to moles calculations in this much detail, spending this much time on it. But I thought you might want to just a quick refresher. I'm under the assumption that you can now quickly transition between grams and moles and grams. Okay. So I'm going to write that over here in my chart. So 0.277 moles. All right, so let me get cleaned up here, and then we will finish the first half of this problem. Alrighty, so I have written down my formula. I have taken inventory of what I know, what it is I'm trying to solve for. Now at this step, I can simply plug and chug. Plug it into my equation and chug through it. So molarity equals 0.277 moles divided by 0.515 liters. So the molarity of this solution, 0.277 divided by 0.515, the molarity is 0.538 molar. So that's the molarity of this solution. What I'm going to do now is I'm going to go ahead and erase everything on this slide, and I'm going to now solve for molality, that new unit. Alrighty, so now the second half of this problem is solve for molality. So remember molality, oh, nope, that's molarity. Molality is still number of moles on top, but on the bottom we've got that mass in kilograms. So taking inventory of what I know, what it is that I'm trying to solve for. Do I know molality? No, that's what I'm trying to solve for. Number of moles, so we solved for that when we did the molarity calculation. So it's the same value, so the 2.77 moles. And then now on the bottom here, we've got the mass of our solvent in kilograms. So if we read through, you prepare a solution by dissolving 17 grams of ethylene glycol in 0.5 kilograms of water. So water is our solvent, and it told us the mass of that water, conveniently. So down here, we've got the 0.5 kilograms. So now I've taken inventory of what I know. I just need to plug it into my equation and solve for molality. So molality equals, we've got number of moles on top. Oops. We've got the mass of our solvent on the bottom. So plug this into my calculator and I get 0.277 divided by 0.500. And the molality comes out to 0.554. For the units, so you can, of course, keep the unit, so you can say moles per kilogram. That would be perfectly acceptable. You also could do the units as cursive or italic M. And the way that we would read that is this solution is 0.554 molal. That's kind of the terminology that we use. So just a quick review of how to solve for molarity, and then a brief introduction of how to solve for molality. We will see molality again this chapter in other calculations. I hope you guys found this helpful.